wrote about rectangular shapings, especially cylindrical. It's an old book where I found this scheme of his. And he organized the various ways of describing or organizing such shapes of high-rise by metaphor, for example, sky prickers, and then there are many variants in it. They can resemble a tube, temple, etc. By the morphology, the articulation of the surface, whether it has horizontal lines, vertical lines. Well, there are many ways to describe it, but none of them is really connecting to the double curved facades. Also, the classical ways to describe them by hyperboloids, boloids, ellipsoids. Hardly anyone understands what it means these days. Or actually, as soon as they leave school, they forget about the meaning of such terms. And nobody on the building site actually knows what it's about. And although they are very precise, they are too precise, if one can call precise too precise. They don't connect anymore to the new ways of drawing these days. They are either ellipsoid, but people would make variations on the system. They are not understandable, or like the morphology system of describing them as a sky cutter or a sky knife. Well, they're not very precise either. So I made a system that is based on computer manipulations, on move, rotate, and scale and merge. Or that's the second generation system that's on the scripting. As you can see in the scheme, one can move a line along a circle, for example, or one can rotate it around the vertical axis in this case. One can take the red surface and then move it upward, for example, along a curve. One can add a rotation and then add that will result into a twister. Or the modern ways, that is first make a rotational figure, for example, and then deform it, bend it. It's all effortlessly done in computer, but it's hard to describe geometrically sometimes. So this system is now based on the computer manipulations, and I made various, there's a build-up in it, of course. The main categories based on the basic movements, and they're very generic. As a principle, I took that only the volumes that are complete are in the scheme. If one combines volumes, the system gets much more complicated. So this is a primary version of the system, but at least it allows classifying most of the buildings, and then the others that are left over can be called compound volumes, and then they have one or more double curved surfaces. And then subcategories, they elaborate on a specific kind of rotation along a helix, for example, or special script procedures. Apart from that, of course, many special categories can be discerned that emphasize a special facade finishing or material or the structural aspects. And with keywords also one goes across all the categories that I discerned. The main categories are the extruders, twisters, rotors, compounders, compound volumes, and free shapers. These are more or less the first generation, like the volumes were drawn in the past. For example, having a surface and then moving it upward, one would end up with orthogonal volume, and I gave them names. If the surface was moved sideways along a straight line, it's an angler or a slider, etc. A rotor has a vertical axis for a start. That's the first generation. Hyperboloid, of course, is a special case, the torus. Because twisted surfaces are very much used in building, because of the straight lines, they are relatively easy to materialize, because they still connect to the conventional ways of producing and of measuring along straight lines. I included also the hypars, hyperbolic paraboloids, and the twisted surfaces in general, especially when they connect up to orthogonal system. Twisters are, of course, often, as the word says, they are built of straight lines also, that are moved upward and have a rotation, which is at right angles to the movement, direction of movement. Twisters have the great advantage that every floor will be the same if the rotation is regular, constant. And then with solid modeling also other shapes could be made, like free shapes, I call them, where lines were drawn between different shapes at top and bottom, for example. And an important building type also is the repeater, where facades of a specific geometry are repeated, which of course implies a much bigger series of elements. The second generation, well, that's it makes much more variations possible on the transforming, and scripting is introduced also in a much bigger way. And thus the tube, for example, is a popular transforming system. It is made by scripting often, and then for example, three-dimensional curve is drawn, and the floor plan of the ground floor is being taken up, and it can be drawn perpendicular to the axis, like the tube of the extruder type. It can also be made with floors that stay horizontal, and then it's a slider, basically, but drawn in a different way. This implies that the second generation way of drawing, it also can be applied for the first generation. New types of buildings that are used also are the bent rotor on the top right and the scaled rotor. I will show examples of those, very big scale examples. And a popular way of drawing also is sweeping a curved line. It's very hard to see, but there's a dotted line that is being as a connection line between the top surface and the bottom surface, or the contour line of it. So these are the main categories that I just described. If one extrudes the surface upward, if it's vertical, it's the ortho. If it's under angle, it's angular, or the slider if it's along a curve. The drawn example, it actually has one twisted tower, that's the one on the right, and one inclining tower. These are the slider variations that are coming up. They can also be drawn by parametric, drawing by scripting procedures. They're very easy to draw, and often it's a choice when making a slider or a tube whether one wants all the floor plans to be similar or to be different. Of course, when they're similar, it has a different geometry on the outside. The volume it can squeeze together where it goes almost horizontal in this case, parallel to the floor. Whereas the tube would have a very wide floor at that point. Well, about half of the projects that I will be showing will be built. The top left, it was a competition, an entry by Herzog de Meuron for Petersburg that they didn't win. The lakes by Edes was a design for Abu Dhabi, which was slightly earlier than the dancing towers of Zaha Hadid, which is the one in the middle. And then to the right there are two typical projects for a tube or a slider. Actually, it's often quite hard to see what the difference is, so we must still get used to the way the volumes are generated, and then we can recognize how they did it. If there are too many manipulations put on a volume, then one hardly recognizes what the shape is either, so then I just call it a free shaper. Probably people will, for a great deal in the first stage, the second generation stage, limit the number of manipulations on a volume, like here, all of them. Maybe I think the dancing towers of Zaha Hadid, it's tapering to the top, which is very easy to script also. But it still is a quite regular geometry. The good thing of having only limited variations on a shape, or of only combining a few manipulations, is that one still keeps a mental oversight of the shaping. It's like the dresses of people, they usually don't have more than 3 colors. If there's 4, it becomes too frivole, too happy, and if it's 2, it gets serious and boring. It can get anyway. And the one on the bottom, it's by a Danish architect, Big. It's designed for lots of functions, multiple function in China. It won't be built, I think. Designed by UN Studio for Busan in Korea. It was a competition entry also that wasn't built. It's often quite hard to exactly define what is the shaping or the manipulation to shape this. Was it a surface that goes up and twists at the same time, or is it only moving sideways? This, of course, is very important for the structure and the facade geometry. Well, the second class after the extruder is the rotor. I gave them names to make it easily to remember. The big thing is, will the name catch up? Will the people remember this and make it typical for such a shape? The time will show whether that is the case. It's most architects will want to connect the name of their building, the type name, by the newest manipulation of the computer, because that's the way they drew it. So in time, as new software is becoming available, the names will change also, which is a pity if one wants to schematize. These are all variations on a rotor. The one with the helical movement upward, it actually is a rotor. Because it only is a line in the facade, and the superstructure would have vertical columns, or only curving in one surface. Also the one by McDonough in the middle, the green and blue facade. I think it has a diagrid in the facade, and connected to that are the shading elements, or the colors of the reflective glass. In the middle, the Russian Federation Towers. Russian Federation Towers is finished, I think. And Swiss Reinsurance, of course, by Foster. I don't really call it a twisting building, because the outside it's structural. It's a diagrid, and it's triangularized. Yeah, and so it's structurally not a twister. It doesn't have twisting columns that go up in helix. The one on the second one from the right, it's a monument from the glass lamp industries in China that they plan to build. I wouldn't be surprised if it was built. I don't know whether they will then burn it actually, or put it to fire. And then there's a tower. It's a communication tower that was not built in Spain. And another high-rise project under it. These are rotors also. And Remco has building, I think, for Abu Dhabi, if I'm not mistaken. It's a globe. The project by Liebeskind, it's a segment of a globe for Milan, the trade fair redevelopment. They are simple parts of a globe, so a regular surface. The Torre Akbar Tower by Rouvel in Barcelona, it's a typical second generation building because it has an elliptical floor plan. And Green Bird, as it's called by Future Systems, about 20 years old I think, it's a bent volume. So, and these all will be built, will be built in some form in the near future. I'm surprised that after I made my first scheme some 5 years ago, that so many buildings that I thought were impossible to build or were unlikely to be built because there was too little repetition of facade elements and construction elements, that they are now really being built. Well, the hyperboloids, as this basic shape is called, are quite popular also because they can be built of straight lines. On the lift, I haven't got all the names here, but they can be found in my paper. The one in the middle, the high one, it will be built. It's a 500-meter tower from China. And the one next to that on the right, it's built in Qatar, I think. It's the good thing of this scheme is that it takes away many of the curved buildings, if I can just call them like that. So what is left over, they may still be free buildings, free-shaped buildings, but at least there are much less of them. And these can already then be categorized and be compared. Twisting buildings with the great advantage of having every window that is top of the other, they will be similar. Here about half of the project will be built also. The third from the left is the U2 tower in Dublin, about 100 meters high. That's of the U2 band, and they will have their own studios there also. The Infinity Tower, that's the second from the right at the top, by SOM in Dubai, of course. And the Calatrava Tower in Valencia. The middle one is on the bottom line, it's by Zaha Hadid also, and then Calatrava building in Malmö. It's going quick. 2 minutes? More on the twister subject. Helical twisters, where the axis of rotation, it's circling. All variations on the theme. 4 of them will be built, or 5. Twins. One can categorize as one wishes. This was just an experiment, as I call it, as it's an elliptical floor plan which is curving and rotating around the 3D axis. All those shapes will be built. This is the twisted surface connecting to orthogonal superstructure and more variations. Free shapers where parts are carved out of another volume. And then the one by the land station, it's a real free shape. A combination of many other things. Repetition of volumes, I call them repeaters. And then there are many other different categories that one can discern. where the outside is approximated by just the balconies or louvers, the rotators, wind energizers. Curved buildings, these are scripted buildings also, the ones on the left. Building groups where the setting should be optimized as to environmental aspects. Special facade finishings, environmental aspects. And well, this is an orthogonal building that I added, but the facade is so much bigger than just having the roof that it should be a part of the green design of a building too, I think. Well, non-standard production is the thing of the future, with lower prices and the twisted buildings as we saw them now coming up, like the Malmö building, won't be repeated for economic use, but because of the symbolic meaning of the lines and the easy to imagine geometry, I think. If one wants to organize or study and compare compound volumes, another way of describing must be made. And with time, people will get more experience with the CAD tools, and new variations, new names will come up. That's about it. The conclusions is that the system works as far as that most of the buildings can be categorized, and that new ones will come up, and that most people understand the simple descriptions of the computer, and it connects very well to the building site actually even. And no mathematical formula is needed anymore. A good book on this topic is Architectural Geometry, which is a standard for the computer drawing in the future. Thank you, my primitive Arabic.